Have you ever wondered how it all began? The universe, the stars, the Earth, the birth of everything we see around us and even the things we don't, began with an event known as the Big Bang. Picture the entire universe compressed into a bubble thousands of times smaller than a pinhead. It's hard to imagine, isn't it? This tiny speck was a boiling cauldron of unimaginable heat and density. Then, around 14 billion years ago, it exploded. This wasn't an ordinary explosion but a titanic outpouring of matter and energy, a cosmic firecracker that marked the beginning of time and space. From this initial eruption of raw energy, the universe began to grow, to stretch, to cool. As it expanded, the energy started to morph into particles of matter and antimatter. These particles were the primordial seeds that would eventually form everything in the universe. In the immediate aftermath of the Big Bang, the universe was a seething soup of particles and energy. But as it continued to expand and cool, matter began to dominate over antimatter. These particles of matter started to come together, forming atoms, the building blocks of everything that exists. As the universe continued to cool and expand, these atoms began to gather into clouds of gas. Under the relentless pull of gravity, these clouds of gas started to collapse, becoming denser and hotter. This process eventually ignited the nuclear fires of the first stars, birthing light into a universe that had been in darkness for more than 100 million years. These first-generation stars lived fast and died young, exploding as supernova and enriching the surrounding space with heavier elements. The debris from these stellar explosions would eventually coalesce to form new stars, planets, and galaxies. And so the universe grew, from a pinhead-sized bubble to a vast cosmos teeming with billions of galaxies, each one a city of stars with its own unique history and future. So from a pinhead-sized bubble, the universe expanded into the vast cosmos we know today, a grand tapestry woven from matter and energy, birthed in the crucible of the Big Bang. But where does our home, the Earth, fit into this grand cosmic picture? Approximately 4.6 billion years ago, the stage was set for a celestial performance of epic proportions. A large cloud of particles, remnants from the Big Bang, began a cosmic dance that would lead to the formation of our planet. In this cosmic cloud, particles began to collide, driven by the fundamental forces of the universe. As these particles crashed into each other, they didn't simply bounce off and continue on their way. Instead, they stuck together, forming larger and larger clumps of matter. Now, imagine a celestial ballet, where each dancer represents a particle, and their dance represents the collisions and interactions that occurred over billions of years. As the ballet continues, the dancers begin to clump together, forming larger and larger groups until they eventually form a single planet-sized ensemble. This is a simplified representation of how Earth formed. But what was the driving force behind this cosmic ballet? Gravity, the unseen puppet master, pulling the strings and guiding the dancers in their performance. Gravity, a force so fundamentally intertwined with the fabric of the universe, was responsible for gathering together these particles of dust and gas, clumping them together to form the Earth. This process wasn't quick by any human standards. It took millions upon millions of years for these particles to come together, to collide, clump, and grow, eventually forming the Earth. And the Earth, at this stage of its formation, was a hot, volatile, and inhospitable place, a far cry from the blue and green oasis we call home today. The Earth, as it was then, would be unrecognizable to us now. It was a world in flux, a world being shaped and molded by the forces of the universe. This was Earth in its infancy, a newborn planet finding its place in the cosmic dance of the universe. So the next time you look up at the night sky, remember the cosmic ballet that led to the formation of our home. Remember the power of gravity, the collisions, the clumping, and the slow, gradual process that brought us here. The Earth as it was then would be unrecognizable to us now. How did the Earth's surface transform into the familiar continents and oceans we see today? Our journey of understanding begins with the concept of continental drift, which later evolved into the comprehensive theory of plate tectonics. This theory serves as the bedrock of geology, explaining the constant yet subtle changes we observe on Earth's crust. Continental drift was first proposed in the early 20th century. It suggested that the continents were not always in their current positions but had drifted over time. However, it was the advent of plate tectonics in the mid-20th century that truly revolutionized our understanding of Earth's dynamism. The Earth's crust, or lithosphere, is not a single unbroken shell. Instead, it is divided into several large and small plates that float atop the semi-fluid layer beneath, known as the asthenosphere. These tectonic plates are in constant motion, albeit at a pace slower than a snail's crawl. But over millions and billions of years, these slow movements have resulted in dramatic transformations. When plates collide, they form mountain ranges like the Himalayas. When they move apart, they create rift valleys and seafloors. And when one plate slides beneath another, it can trigger earthquakes and volcanic activity. It's fascinating to consider that the landscapes we see around us today are the results of these slow yet powerful tectonic processes. The majestic mountains, the deep ocean trenches, the vast plains, and even the locations of earthquakes and volcanoes are all products of plate tectonics. The theory of plate tectonics also explains the existence of past supercontinents such as Pangaea. This landmass comprised all of today's continents, fused together in a single entity. Over hundreds of millions of years, Pangaea fragmented due to tectonic forces, and its pieces slowly drifted to their present positions. So, the continents and oceans we see today are simply snapshots of an ongoing process. They have been constantly changing throughout Earth's history, and will continue to do so in the future. Plate tectonics, the unifying theory of geology, continues to shape our world even today. Did you know that our continents were once a single mass of land? Picture a time when there were no 7 continents, but one giant supercontinent. This supercontinent was known as Pangaea, a name that aptly translates to all lands. Formed approximately 300 million years ago, Pangaea was the result of Earth's tectonic plates coming together, converging to form a single, massive landmass. Imagine for a moment the world map you're familiar with. Now, visualize erasing the boundaries of the 7 continents, merging them into one. It's a fascinating thought, isn't it? This is what Earth looked like during the late Paleozoic and early Mesozoic eras, a time when dinosaurs roamed the planet and the first mammals were just beginning to appear. But how did this supercontinent form? The answer lies in the movement of Earth's tectonic plates. Just like puzzle pieces, these plates are constantly moving, albeit at a pace slower than the growth of your fingernails. Over millions of years, these slow movements can result in significant changes, and it was these movements that brought all the land masses together to form Pangaea. However, as with all things in nature, change is the only constant. Approximately 200 million years ago, Pangaea began to break apart. Once again, the tectonic plates were at play, this time moving away from each other. Over the course of millions of years, the singular landmass of Pangaea fractured and drifted apart, forming the continents we know today. But here's the fascinating part: Pangaea wasn't the first supercontinent, and it certainly won't be the last. Earth's history has seen multiple supercontinents form and break apart, and even now, our continents are slowly on the move. So, the next time you look at a world map, remember that those continents weren't always where they are now. They've journeyed across the globe, coming together and drifting apart, shaping the world as we know it. Pangaea, the All Lands, is a testament to the Earth's ever-changing surface. So, what is the significance of understanding Earth's journey through time? Well, it's really all about perspective. The tale of Earth's journey is a compelling odyssey that began in the fiery heart of the Big Bang, about 14 billion years ago. This colossal explosion gave birth to the universe as we know it, creating matter and energy out of an incomprehensibly tiny and dense point. Fast forward to around 4.6 billion years ago, a cloud of cosmic dust and gas coalesced due to gravity, forming our home planet, Earth. Over the eons, Earth has transformed from a hot, hostile world into the life-supporting planet we inhabit today, thanks to the ceaseless dance of tectonic plates beneath its surface. The concept of plate tectonics, a unifying theory in geology, provides us with insights into the dynamic nature of our planet. Continental drift, a key component of this theory, has shaped and reshaped the face of Earth, creating and destroying land masses over billions of years. One of the most intriguing pieces of this geological puzzle is the existence of supercontinents. Pangaea, a term that means all lands, was one such supercontinent that existed around 240 million years ago. It started breaking apart about 200 million years ago, eventually forming the continents as we know them today. But Pangaea was not the first supercontinent, nor will it be the last. The Earth's crust is in constant motion, and continents will continue to drift and reform. This reshaping of our planet is an ongoing process, a testament to the ever-changing nature of Earth and, by extension, life itself. By understanding this journey, we gain a deeper appreciation of our place in the universe. We are but transient inhabitants of a planet that has existed for billions of years, and will continue to exist for billions more. It's a humbling reminder of our insignificance in the grand scheme of things, yet it also emphasizes our responsibility to protect and preserve this precious world for future generations. From the Big Bang to the formation of Pangaea, the Earth's journey through time is a fascinating tale of cosmic events and geological transformations.